Maybe a Starburst flavored coffee. Somebody told me Taco Bell now makes a Starburst flavored slushie.
Yes, and we're
Is it good?
about it. It's pretty good.
Oh, it's good. Okay. It sounds heinous, but it's good though.
Oh well, it probably is for you. But
Well, no. It tastes good though. That's what I mean.
yeah.
What's the Slurpee place in town?
7-Eleven.
Not 7-Eleven. Not 7-Eleven. I'm using the wrong phrase. Smoothie place.
Jamba
Juice. I don't know if they still do it. They make a pumpkin pie smoothie for fall. Holy crap. It's gotta be like 8,000 calories, but you've had it, Sumi, it's so good. It's so damn good. It's like drinking a pumpkin pie, which if you don't like pumpkin would make you nauseous, but my God, it's good. All right, anyway, back to this little shot for Jamba Juice, a little free advertising for. What's the chance of winning? So we already know this. The chance of winning, I'm having a hard time spelling, winning. Experimental was 12/25, yes? Which is right around 48%. Actually, it is 48%. It's a 48% chance of winning, according to our results. 48% of us won. Fair enough? Okay, good. Now, what's the chance of winning theoretical, which is exact? Okay, so the first thing we have to do is, let's break down what it means to win. How many different ways can you win in this game? Okay, so, for starters, what can you get? You might roll a 7, right? So we're going to roll a 7. That's one way. Before we do any numerical crunching, let's just write out all the ways we can win. So you might get a 7. So the chance of rolling a 7. How else can we win? Let's add to that.
11.
Or 11. Good. How else can you win?
You roll a 6 and a 6 and a 7.
Okay. Well, before you roll a 7, correct?
Wait.
Once you roll a 6, then 7 is your friend only on the first roll. As soon as you don't roll a 7 on the first roll, you don't want to see a 7 again until the next round. The only time a 7 is good news for you is on the first roll. Other than that, it's your mortal enemy. Right. So let's just go through this one by one. How about rolling a 4 twice before a 7? Yes? That's one way to win. How about rolling a 5 twice before a 7? That also works, right? 5 twice before a 7. Can I use a shorthand for the rest of these? Is that okay? Jessica's like, please, thank you. How about 6 twice before a 7? That's a little bit nicer, isn't it? What else?
8.
8 twice before a 7. What else? 9 twice before a 7. What else? 10 twice before a 7. What else? Oh, that's it, actually. That's it. And that accounts for every possible thing that can happen, because if you roll a 2 or a 3 or a 12 on the first roll, you're done. You cracked out. If you roll a 7 or 11 on the front, you win. You get your ante back plus 1. Everything else gets interesting. Everything else gets interesting. And that's where these rolling twice before 7 things come in. With me so far? Believable. Okay, let's calculate them together now. Now you have to think back, and it's been a week now, and that's okay if you don't remember this. We have to think back about when you roll dice, how many things can happen when you throw dice. Do you remember from either your last project or from the discussion we had last week, when you throw a pair of dice, how many things can happen?
36.
36, right? 36 possibilities can happen on the first roll. Good. We're going to use that. So what's the chance you roll a 7?
1 in 36.
Oh, it's not that crappy. That's just snake eyes. It's 6 out of 36, isn't it? Think about why. Grab your dice. Grab your dice. Figure it out right now. It's easier if you have 2 different color dice. But there are 6 different ways, right? Make 7 on your dice. Make 7 on your dice. No, just actually grab them and turn them and make 7. Now make 7 again. Yeah, start switching them around. Exactly. Make 7 again. Make 7 again. I know it's like a broken record. But there's a lot, it's the most common roll because there's the most ways of making it. 1 and 6, 6 and 7, 2 and 5, 5 and 2.
3 and 4, 4 and 3.
Yes, there's 6 ways to do it. 3, 4, 4, 3, 2, 5, 5, 2, 6, 1, 1, 6. Why am I saying them everything twice and backwards? 1, 6, 6, 1.
Not enough coffee.
Not enough coffee?
I don't know, I thought you were messing up.
Oh, no, 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 no! Not enough coffee. Go drink some more! Go to bonus cup! No, 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 because you have 2 dice. This is why it's easier to see with 2 different colors of dice. I'm sorry, I just kicked. I thought that was your foot. It's the table. 1 red, 6 green is different than 1 green, 6 red. Those are 2 different rolls, yes? Good. So there's a 6 in 36 chance of rolling a 7 and ergo winning on the first roll. Josh?
Would it be easier to just to simplify to 1 out of 6?
Let me let you decide after the next computation. Okay? I don't think so personally, but this is my opinion and therefore suspect. What's the chance you roll an 11? Ooh, while we're doing this, I'm going to fire up the projector too. What's the chance you're rolling an 11, friends? I hear 2 out of 36.
She's right.
5 and 6, 6 and 5. There's only 2 ways to make it 11, right? 5 and 6, 6 and 5. That's it. There's no other ways to make 11 with these dice. So this guy's 2 out of 36, and that's why you can't do that one out of 6, Josh. Well, you could. I guess you could make it point.
Yeah.
333 out of, yeah, let's just leave it 30 out of 36. So we're up to 836 now, which is yay, that's good, that's good. Except we're not done yet. We still have all these other ways to win. Yay, us. Yes, oh my God. Now this is where it gets really interesting and really fun, in my opinion. Now you don't have to agree with me, of course, but I do think this is interesting and fun. What's the chance you roll a 4 twice? Well, before you roll a 4 twice, you got to roll a 4 once. What's the chance of rolling a 4?
3.
3
4.
out of 36. Count them up, count them up, count them up. Make 4 on your dice. Make 4.
2.
Now make 4 again. Now make 4 again.
Can't. 1 and 3.
You're done at 3, aren't you? 2 and 2. 1 and 3. 3 and 1. Why am I not doing 2 and 2, 2 and 2? Good. That's a good. I don't know. Let's answer that question. May I borrow your guys' dice because they're 2 different colors? Okay. I'm going to start by ignoring the 2 and 2 and going to the 3 and 1, 1 and 3. So here's 1 and where's 3? There you are. 1 and 3. Notice it's a red 1 and a green 3. Now I'm going to go red 3, green 1. That's a different roll, isn't it? So now I'm with the 2. Now I'm going to go 2 and 2. 2, 2. Okay, there I go. Now, do 2 and 2 again. You can't. I mean, I could go like that. But that's still the same 2 faces looking up at me. Even if you switch them like that, it's still the same 2 faces looking back at you, isn't it? So there are 3 in 36 ways, English. 3 in 36 ways of rolling a 4 the first time. Now here's a preview for those of you guys taking 243 with me. Or with Donna, but with anybody for that matter. When you're calculating probabilities, sometimes you add and sometimes you multiply. And here's a crash course in when you do what. Notice how we added back here? We're adding here. If you were to verbally talk about the ways of winning, playing craps, think about how you would say it to your neighbor, trimming the hedge next to your neighbor. Well, to win in craps, you either got to roll a 7, or an 11,
or a 4.
You hear that word you're using? Or means to add in 243. When you're adding probability, you don't have to memorize that right now. I'm just giving you a heads up. When you're talking about or, that means you're increasing probabilities, which means you're adding to them. You either get this way, or that way, you're adding them. We're about to multiply, and you're about to see the other important word in multiplication. We have to roll a 4 twice, don't we? So that means we have to roll a 4 once, and then roll a 4 again. It's not an or. It's you have to do it this time and then that time. So it becomes a multiplication. Now here's where it gets super tricky. It's not 3 and 36 anymore. It's 3. There are 3 ways to get a 4. But this is where craps is brilliant. You roll a 4 on the first roll, 3 and 36. That's going to happen 3 36 at a time. If you roll a 10 next, does that matter? Doesn't matter at all, does it? That 10 doesn't matter. Although that 10 did matter in this 36. Those 10s are in there. So are the 11s. So are the snake eyes. So are the boxcars. There's lots of rolls in the 36 that no longer matter once you've established your point. The only rolls that matter now are whether you roll a 4 or your nemesis, the 7. Those are the only ones that matter right now. So the only outcomes that matter to you playing this game are the 4, of which there are 3, and the 7, of which there are 6, which means there's a 3 in 9 chance you're going to roll a 4 before a 7. That is one of the hardest moves in probability to understand right there. And if you don't get it 100% right now, don't worry about that. It's more of like a 243, 244 level of probability. Don't sweat that though. I just want you to understand, rolling it on the first one happens 3 out of 36 times. But then matching that 4 again is not the same, because think about all those, how many of you guys had those crazy point rolls where you were throwing stuff in the middle that didn't matter? All of those mattered here, but they don't matter here. So your chance of rolling a 4 has to go up, because there's fewer things distracting you from getting the 4, just those pesky 7s. So 3 and 36 is 1 in 12, 3 and 9 is 1 in 3. It's a great chance of rolling a 4 before a 7. Still a better chance of rolling a 7. Fair?
So,
Me.
okay,
Damn, go.
So your 9 is how many times you can roll the 7.
That's how many possible outcomes are of interest to you, right? Because 3 of them are the 4 and the other 6 are the 7 that you're trying to avoid, yes?
Okay.
Is that fair?
Yeah.
Now watch how that plays out with the rest of them, because it does play out. And move these down because we're out of space. How about 5 twice before a 7? Well, first, we have to roll a 5 on the first roll. So go back to your out of 36. How many ways can you roll a 5? Count them up. Count them up.
4,
There's 4 of them, aren't there?
Yeah.
1 and 4, 4 and 1,
3 and 2.
3 and 2, 2 and 3. Thank you, Mary. So there's 4 out of 36 on the first roll. Good so far? Fair? Now we got to do it again. But now that you've established your point, the 10s fall away, and the 6s fall away, and the 2s and the 3s and the 12s and the 11s, they are all meaningless. You still have 4 5s to roll. But how many numbers are you concerned about now?
The 5 and
The
7.
4 5s
And the 7.
and the 6 7s, which is 4 tenths. Right? Follow the logic there. Follow the logic. There's always going to be 6 7s added in down here. There's always going to be 6 7s added in down here. The number up here has to be added in too, because that's part of what can happen are those 4 5s. So 10 total outcomes you're interested in when you roll a 5 first. 4 of them are 5s, and the other 6 are the 7s. Realize you don't have to roll the exact same 5 both times. That's called 5 the hard way, which is actually worth more betting. If you roll a 1 and a 4, you have to roll a 1 and a 4 again. I'm not betting that way in here with you guys. You're just getting the sum. Fair? Let's keep it going. Plus. Okay? We gotta get a 6 before we get a 7. Okay, what's the chance of getting a 6?
5.
It's 5, isn't it? 2 and 4, 4 and 2. 1 and 5, 5 and 1. And 3 and 3, which we count 1 time because of the whole two color swapping the hands around. So you've got a 5 and 36 shot of doing it on the first roll. That's the kicker. You have to roll it first, and that's always going to be out of 36. Josh, go ahead.
So would that be multiplied by 5 over 11?
Yes, he's got it. So now, what's the chance you roll it again? Well, you still have 5 ways to make a 6. And the denominator still has those 5 ways in it too, but it also has the pesky 6 7s. So it's a total of 11 outcomes. 5 out of 11.
Can you just multiply and then
We-
subtract and then do that?
We can. I'm trying to leave everything out so we can see the construction of it first. Ash, we're about to collapse this all down into one calculation in a second. Promise. Promise. Good so far? Let's keep it going. Let's finish it off. We have 3 more to do. 8 before 7. You're about to see a pattern arise. How many ways can you roll an 8?
5.
The same exact way you can roll a 6. 4 and 4, 2 and 6, 6 and 2, 3 and 5, 5 and 3. Rolling an 8 is just as probable as rolling a 6. You guys figured this out about a week and a half ago. It's okay if you forgot it. It's totally fine if you forgot it. So it's 5 and 36. That's the first 8. Now you got to roll an 8 again before you roll a 7. What's the chance of that happening? Yeah, it's 5 over 11 again. An 8 and a 6 are the same from probability's eyes. Yeah, they're different sums. But as far as the chance of getting an 8 or a chance of getting a 6, they're exactly the same. And getting, I've erased the other two, I'm going to put them back on the board. We got to get a 9 before a 7 and a 10 before a 7 too, don't we? 9 before 7. What's this T?
Twice.
Oh, twice, that's what it is. 9 twice before 7, thank you. 10 twice before 7. 9 is going to mirror... Exactly. 9 is going to mirror 5. Think about how many ways you get 9. 6 and 3, 3 and 6. 4 and 5, 5 and 4. There it is. I almost said 2 and 7, but you can't do that. So, it's going to be 4 out of 36 times 4 out of 10. The chance of getting the point the second time is a lot higher than the chance of getting it the first time. But it's, yeah, this is genius. This whole game is just mathematically brilliant. You're about to see why. Last but not least, 10 is going to match 4. 10 is going to match 4, right? There's 3 outcomes, 3 correct. There are 3 outcomes, right? 5 and 5, 6 and 4, 4 and 6. So 3 out of 36 times 3 out of 9. That mess, all added together, is your chance of winning on any given round. Holy crap! Now, if you want, I'll just do it up on the board and we'll call it a day and then use that in our calculation. Is that okay?
Yeah.
It's a bear, but we'll do it together. We'll do it together. We'll use Google. Oh no, I can't. I didn't fire the computer up. We'll use the TI.